are going to talk about stack. What is stack? Stack is a data structure. If I say data structure is arrangement of data in a systematic order or in a systematic manner, so that it can be handled efficiently. So why this handling of data in systematic order is necessary? It is because if the data is not arranged in a systematic manner, that would be difficult to access the data. Just take an example of a dictionary where the data is sorted, so we can find any word of our choice. Okay, so what a kind of data structure? That's a mechanism by which the insertion and deletion can be done from the one end, which is called as the top of the stack. So to insert a data or to retrieve a data, we have only one door through which we can insert or we can retrieve. That being said, let's will just implement. We can implement that stack data, or I would say the stack structure in either in using an array or with the help of the linked list. So in this video we'll try to implement stack data structure using an array. So first we'll write a C code to do that. So the functionalities which are available with the stack is or we can say the interfaces are something which we need to push the data, or we need to give a data to stack, that is called as the push operation, and if you want to retrieve data from the stack, that is called as the pop operation. And some more so the functions, we can list out the functions or interfaces. So one is push, the other one is pop, which is basically a retrieve data from the stack. The some more thing we can write is called as the top of stack, which is basically it will return the data which is at the top of the stack. One few more function we can design, which is one for print, one for check is that stock is sorry, that means stack is full or not. The one more function is the stack is empty or not. So basically these are the things we need to provide if we try to design a stack. So in this C code we'll design a separate function for each interfaces, and we'll try to implement this. Now here, as I said, we'll design this stack implementation using an array. So first we need to declare one array which has to be global, because all the function need to access this. Otherwise I need to pass this array or array of address of array as an argument, so that all the function can access it. So just for simplicity I'll declare one global array. Here I will provide some max size so that I can check whether my stack is full or not. And here I will given here define this max as 5 using macro. So to C code I'll include the necessary libraries. Of course it's an stdlib. The one more library we can include, because I'll be using one exit function which is in stdlib.h, and main function which is the starting of the main code. Okay, so first we'll define a prototype for this each function, and then we define the function. So the prototype for the push function would be, it has to take one argument. That argument will be of integer type, and that integer data will be passing to the index, will passing to the stack. So the return type would be void. Function name could be anything, but we'll write push just for simplicity. And here we'll write one integer. Here we don't need to mention a variable name, as because it is just a declaration of function. And the data type for void, the declaration for the pop function would be integer return type and just the function name. It doesn't need any argument. Now the top of stack, where type declaration would be just a top of stack, and it will return one integer. Print function, we can define nothing has to it has to print nothing data. And the one more function is called isEmpty. We'll just simply write int is full and is empty. So the declarations of all functions we have given. Now we need to define a function for that. So okay, so the definitions of the push function should be, it has to take one integer. So that element, first my index has to be increased by 1, or I would say my top variable, which I haven't declared yet. So we'll define one global variable which is having a value of -1. Why particularly -1? Because whenever I want to add a first data, it has to be at a of 0, that means at index of 0. So first I will give the value as -1. Now first time when I push the data, I'll increment this value by 1, so that value would become 0, and the a of top would return me the first element of an array. So I'm just whatever value I am getting as an argument, I am giving as the a of index, that means a of 0. The second time it would be at a of 1, and the third time it would be a of 2. Like this it will be doing. Now we'll define a function for pop. As we've decided, the return type would be integer. Here we will declare one local variable on through which we'll able to pass the data to the main. So I'll write a of top, and then I will decrement the value by 1, and I will just simply return this value whatever I got in this variable n. Okay. Now we'll define a print function. So print function would be just one local variable we'll declare, just to make sure that we are using it in our loop. Now we'll initialize with value 0, we'll increment it till top, and one by one we'll print all these values. A of I, and after doing this we'll provide one /n, just to make sure that our output is a little bit formatted. Okay, so the functions of push, pop and top of stack we have already push, pop and print we have already defined. And one more function we'll write, which is of course top of stack. Basically it will return the value whatever it is currently pointing by top of stack. So we'll just simply write a of top. Okay, so we have already defined a function for push, pop, top of stack and print, so we'll get rid of this. And here we'll write one integer isFull, and one more function will write integer isEmpty. And why we need particularly these two functions? Because this max size we have already defined, which is in our this program, it is defined as 5. That means if I keep on pushing the data one by one, if I already pushed 5 values, and if I try to push one more element, it has to say the stack is full. We should not allow user to push the data which is more than its stack size. And the empty function is needed because whenever the user is popping out the value, this index would be decremented by 1. So if there is no data on stack, user should not be allowed to pop the data. So is full, we can write that if my top value reaches to greater than or equal to 4, simply I just need to print stack is full. Okay, and in empty function I just need to write if my top is less than or equal to -1, I need to write stack empty. Okay, so in main function we'll be calling these all functions. So we'll write one option, so giving the user to choice what he want to do with that. The first would be push, second would be pop, third would be print, fourth would be top of stack, and of course it would be for exit, giving user to terminate the program whenever he wants. And we'll scan this value. And now check a multiple condition, either we can use if condition, but I would like to choose switch case. So in switch case I'll be checking the value of option, value of OP variable. If the case is 1, that means user has selected push operation. So first I need to ask the user what value he need to pass, or what value he need to push the data. Of course I need to scan that value too. Okay, so one more variable I need to declare here, and I will be calling this function push, and I will pass this data and I will break the loop. But before doing this, why can't I check one more thing? If stack is full, that means if 1 is equal to is full, then I'll just simply break this loop. So is full should return 1 whenever the stack is full, but I have just made one print statement which is not enough, so I need to return this value. In empty case also I can do the same thing. Okay, so I will return 1 whenever the stack is full. Okay, or I will return 1 in isEmpty function whenever the stack is empty. So first of all, whenever I want to push the data, I will check this condition. If my isFull returns 1, that means I have already added more than 5 value. I won't allow user to enter one more. I will just simply break the loop. The next condition would be case of the popping the data. So here I will just simply write the popped value. The popped value is okay. But here again I can check for these stack is empty or not. So if 1 is equal to is empty, I will simply break this loop. That means if user want to pop the data when there is no data in stack, so I will just simply write a break loop. Okay, the next things which I want to do is print the data. So if my case is 3, I will just call the print function to print the stack data. Next case I will be doing the top of stack, which is just to simply return the value. So I can directly print it in a print function, which is top of stack would give me top underscore of underscore stack, which is function name. Case 5 would be the exit one. Okay, you might be thinking why I have included another library stdlib.h. Just because this function which I am using is declared in this stdlib function. And also I can check a default condition when user has given invalid options. So I will just simply prompt the user that he has entered invalid options. So I can write here invalid option. Okay, but this loop has to be continuously running, so I will just put this all things in just one while loop. While 1, that means forever true. So it will keep on rotating this statement until we press that 5 key, that means number 5, because in 5 we have written exit function. So once again we'll check is there any. Okay, so we have included a library stdlib2 instead of stdio.h. So that was the one error. Now the function looks pretty good. Products we have already defined. One variable, top variable. Now we're doing this. Okay, I think we are good with that. So the definitions of function are ready. Now we can compile this code. First we'll check if there any error is there or not. so looks fine. Okay, so here in false condition we can return the value 0. That means if this function returns 0, that means the stack is not full. If it is returning 1, that means the stack is full. And the same thing we can do for the empty function, return 0. Now we'll compile this code and we'll run it. The first thing which I want to try with this implementation of stack is I want to pop the data. So I will provide two value just to make sure that popping doesn't work when we haven't entered any value. So it is saying stack empty, that means it is working correctly. Now I will try to push data. The first value I have pushed is 20. The one more value I want to push, there is 20. Now I will try to print the value of stack. So currently on stack 10 and 20 the data are there. And now I will try to print the value which is at top of stack. So it should give me a value 20, which is working correctly. Top of stack is returning 20. So three more value I will push into the stack. One is 40 and 150. Now I will print this all values. So currently stack is having data 10, 20, 30, 40 and 50. Now if I want to add one more value, it should say me stack is full, which is saying stack is full. Now I want to see the top of stack, which is 50. Now I will try whether my pop function is working correctly. So I will check that by pressing key 2. So popped value is 50, that means currently on top of stack it should be 40, so which is giving me correct. And option 3 should give me only 4 value, which is 10, 20, 30 and 40. So it is working fine. Now for all the values I will try to pop from the stack, and now if I try to pop one more value, it should give me stack empty. So this implementation is working correctly. So this is how we can implement stack data structure with the help of array. In next video I'll be implementing that stack data structure with the help of linked list. So thanks.